If you want to become an AI engineer in 2026, you're entering a field that barely existed a few years ago. AI engineering, actually taking models and building real systems with them, that's new. But here's the problem. Because it's so new, there's a lot of bad advice out there. People telling you to spend years learning all the math, master every algorithm, understand everything before you touch a real project. That's going to waste months of your time going in the wrong direction. In this video, I'm going to give you the exact steps I would take if I had to start from zero today, month by month, what to learn, what to skip, how to build projects that actually stand out, and how to position yourself so companies come to you instead of you chasing them. Here's the thing, I learned AI and machine learning in about 3 to 4 months. Not master it, but I understood it enough to land my first job building prediction models to predict the stock market. Since then, I've built AI software for Apple Vision Pro, I've built AI for self-driving cars that actually drove on a closed circuit, I co-founded an AI company and went through several rounds of funding. I have multiple AI patents. Y Combinator reached out to me without me applying to their accelerator, and companies like Apple, Google, Meta, and Netflix headhunted me for AI positions that I didn't even apply for. But here's what most people don't know. I came from film and 3D animation. I was doing rigging and visual effects. I was a CG supervisor for Teenage Mutant Ninja Turtles Mutant Mayhem. That is not your typical background to get into AI, not even close. So if I had to start over today in 2026, knowing what I know now, what would I actually do? By the end of this video, you will have the complete roadmap, the exact skills you need, the projects that will make you stand out from everyone else doing the same tutorials, and a strategy to get you hired. Let's get into it. So why is 2026 different? Well, the AI path has fundamentally changed. Before, in the past, the old method was basically learn deep math, like statistics, and also like calculus, like gradient descent, backpropagations. Now the thing is, the models already exist. So all you have to do is put them together. It's been like a decade since these things are being created. A lot of papers come out. It's a huge boom right now. Now the thing is, companies don't need researchers unless you're working for like Meta and you're actually working as a researcher with a PhD and you're going to conferences. What companies need are actual builders who actually get the job done and actually solve a business problem. Right now, the market is flooding with tutorials of like how to get started on things and show you just sample toy projects. But what companies need is someone that actually solves real problems. Standing out is the actual goal. So I'm going to give you the roadmap to actually stand out. So month 1, you want to learn the foundations here, right? So month 1 is the foundation. What that is basically learn Python. This is mandatory. Basically machine learning, deep learning, all is using PyTorch, Python right now as their main de facto code. So if you're going to see the latest paper or implement a model, even if you're not actually using the paper, it's in Python. The other thing I would say is actually learn just in time. What I mean by that is you don't learn absolutely everything you need to know about a subject. You learn what you need to know to get by. Think of it as if you're going to a new country, and if you're in there for about 2 weeks, you're going to start picking up the language. Or think of like children when they're infants. They don't go to class to learn their language. Just being in the environment, they pick up on what's needed to get by. That's what you actually want. And this goes and feeds into the next section, results over clean code. Basically, the end result you're trying to get is actually something useful as opposed to making sure everything's done correctly. It doesn't matter if your code is perfect and clean and approved if it doesn't actually get any types of results. And the other thing in terms of the foundation you should learn on top of Python is actually the core data science stack. And what that actually is pretty much you want to learn NumPy. That is numerical Python. It's part of Python. If you look at Python, you'll learn there's different packages. NumPy is basically a math package that gives you much faster speed and can deal with big data. And that's how machine learning actually works. So if you ever heard before, like C++ is faster than Python, well, if you're using NumPy, you start getting into territory where it's actually fast enough to do calculation. The other thing you want to learn is pandas. That is basically, think of it as actually using like Excel. Take Excel sheets that you could export out and actually process the data with that. And the last thing you want to make sure you learn is Matplotlib or Seaborn. And basically what that is to visualize the data. So these are the core things that you would need to know on your actual stacks. And the other thing about this is that there's no hardware barrier at the moment. You don't have to go in and buy the most expensive computer because you could actually go, if you have a Gmail account, get Google Colab or Collaboratory or Collaboratory. I'm not sure how they actually spell it out. It's like laboratory, so I guess Collaboratory for that. So if you have a Gmail account where you could go into like G Drive or Google Drive, it comes free with your Gmail account, and you can actually create like Google Docs, which is like Microsoft Word, but it's free on Google. Google Sheets, which is like Microsoft Excel. But there's actually more things you could create. When you go and create a new one of these types of documents, there's usually a 3-dot, and one of them is Google Collaboratory, and that allows you to do basically coding Python, and you could use GPU and CPU. So you could start using Python today as long as you have an internet connection and you have a Gmail account. Month 2 of your basic roadmap is to start learning machine learning fundamentals. So start learning ML or machine learning without the deep neural networks or just neural nets. You don't have to build them all from scratch. You could actually use, again, you're learning Python. There's another package called scikit-learn, and what that does is basically has the classic algorithms and the classic machine learning that's models that are classic, that are used all the time, and it's built in directly, so you don't have to actually implement the code, you just use it. So, and other thing about it is use it as baselines, like simple things like you learn in statistics that still works today, like linear regression. You'll have it built into these libraries. Learn how to use it, because the reason why is because in the real world, a lot of these classic algorithms still work. You don't have to have the most complicated PyTorch deep learning neural network for things to work. And if you do require it, then the thing is that this at least shows you a baseline saying like, hey, look, classic algorithms doesn't work in these cases. This is why we need to go into deep learning. And the other thing about this is that you start learning more that the actual algorithms itself are not as hard as working with the data. That's what actually dominates machine learning. So that's why it's very important that you have to learn the data science stack, even though you have to become some level of a data scientist or learn how to manipulate data in general, because that's an extremely important part of machine learning. And even if once you learn these basics and you start learning working with models that already exist, you still have to manipulate the data in the real world. And the other things, you want to learn the engineering fundamentals. So how do you use source control like Git? How do you actually manage your code? How do you make virtual environments so each one works? And how do you put it, let's say, in a Docker container and deploy it so it packages up, and you avoid the problem of, okay, well, it works on my computer, but it doesn't work on this computer, right? And the thing is about this, the model architecture, the AI, the part that everyone talks about, that's only a small part. Dealing with all this extra overhead is where the real work begins. And this is how you separate yourself from everyone else, if you know how to do these things. Now, you're on your roadmap, month 3, what you're going to do is you'll actually start learning more deep learning and modern AI, how it is today. So deep learning, basically, if you have a neural network, if you have more than 2 layers, it's called deep learning. So that's just kind of like the buzzword. And usually once you start going into that, it's something a little more complicated. That's where you're going to learn more of like the production deep learning tools such as PyTorch. That's the main mainframe now, that's framework that's used nowadays. In the past, used to be TensorFlow, and you might still see some people might use it. There's still other framework. You can even build it yourself, but PyTorch is pretty much the de facto. Every paper and every implementation is pretty much using this, right? And the thing is, you want to use deep learning for more complex data that you weren't really using when you're in the month before, when you're using scikit-learn and you're just using basic machine learning and classic algorithms, right? So we're talking things like if you're dealing with images or videos and things like that, that's where learning starts shining and simple models don't work as much, right? And the training mechanics, that actually matters. How do the models are trained, and how do you put in inference, meaning actually making predictions? The models or the AI models actually doing something. You learn the basics of that in the month before with machine learning basics and using scikit-learn. But here, it really comes full force because you're dealing with big data here, right? And the other thing is the power of the transformers. And in 2017, 2018, around that time period, a paper was released from Google and on the transformers architecture. And that architecture is kind of like what dominates now. So you should at least read that paper to find out the transformer model architecture and how it works, because that is what makes modern AI possible these days, right? And the other thing you want to learn is what is agentic and LLM workflow. So LLM is a large language model, and you basically want to use this. This is how what everyone's used to right now. And the other thing is agentic is that one thing is the large language models are notorious for is, for example, at the time, at this time, they're not really great at actually doing basic mathematics, right? So it might try to seem confident and the answer might seem good when you read it, but when you actually work out the math, a lot of times doesn't work out well. So instead of trying to train the model to be great at critical thinking for mathematics, you could just attach like an outside program such as a calculator or Python, for example, that the model will offload it to like an agent to do the calculations or do extra work and come back and manipulate the data afterwards. So this agentic workflow helped, and plus other things like RAG as well, helped really boost and how models work today. And you should learn how they work as well to see how it can advance, because you could actually implement that yourself to make your models better. Month 4 and beyond, that's where you actually start working on real projects, because the first 3 months, you know enough of the foundation to start actually applying it. Here, I really would suggest stop doing tutorials and actually build real projects. Find something like, if you're in your specific domain that you know that's a problem, and try to apply machine learning algorithms to solve it, AI engineering and whatnot, and actually use real data, because it's actually messy. You'll find that in month 2, when you start using like scikit-learn or start dealing with data science, when you're doing tutorials, they'll give you the data from like Kaggle websites or from consensus websites done by like the government or whatnot, and from surveys and whatnot. They get the data, they're perfectly curated, they're perfectly aligned and named, and all the data points are there. In real world, the data is messy. You want to actually use data that's representative in the real world, like in your actual domain. For example, if you're in sales, retail, for example, and you want to track and use machine learning to figure out what are the habits of their customers, you might want to get the data from a POS, like a point of sale system, and actually find out, like, for example, you might have missing dates, or the dates might be not consistent, where some of them might formatted day, month, year, others might be year, month, date, or something like that, or month, day, year. So the thing is, how do you process that data beforehand and make it work? At the end of the day, you want to build an end-to-end system that takes messy data, you know your domain knowledge, it's actually a real-world project, and it actually gives an end result that is pertaining to that domain, that someone that like, hey, if I had that solution, I would actually pay for it, right? And I would say do at least 3 projects minimum, because the first time it's going to be rough. You don't know what you're doing. That's normal. Nobody starts off a master, nobody hits a home run on their first swing. But you go through what you trying to apply what you learn from the tutorials into the first real project. The second time, that's why I say do 3, because the second time you're going to be a little better, because you're going to know all the gotchas from the first one, and then you're going to do, okay, I know I made these type of mistakes the first time, let me try to correct it the second time. And then the third time, because now you've done it kind of like in a much better way, you'll feel a lot more confidence, right? The other thing is, when you start off a new project, right? Or the other thing as well, like when you go to other businesses and show what you're doing, you might not feel as confident at the beginning, right? But doing 3 projects that are 3 real projects, you're going to build evidence, right? And if you don't have confidence, building evidence that shows that you're competent. So competence builds confidence from that. This is another thing. And the other thing is, when you go to businesses and you show real projects that's actually domain specific, and you document the workflow as you're doing it, and you show the business impact and how the bottom line is affected for them, for whatever measurable impact there is for them, they're actually going to appreciate it. Now, the other thing you're going to be doing in month 4 is also your job hunt strategy. You're starting from that point. So the idea at this point is that you're doing real projects, you're going to start applying for jobs. And the thing is about it, the strategy is more important than the skill set, because right now, if you're going to apply for jobs just out there, you're not going to stand out from anybody, right? So you want to apply before you're ready, because it's actually going to take time. It's not like you send out a request and you get a response within like 15 minutes or even a week, right? There's a lot of people you might not get a response at all. So the thing is, you want to have it built into your routine, that like you wake up, for example, an hour a day, you send out 5 job applications every single day. After a while, it's going to basically add up. That's why you want to do this daily and put it as a routine over here, right? The other thing is, you want to target domain companies that you know that the problems and the projects you're working on and the skill sets you have actually have a business impact for them, right? And The other things as well, the interviews itself will actually test implementations or check basically what you've done and ask you questions about it. So actually doing these projects will actually help you in regards, because you can actually speak to how you can actually help the company. And the other thing as well, when you speak to them, you want to communicate of the value of the business itself. That's your actual communication. You want to put everything in the lens of, you do this so it works for your business, and this is how it helps. Either it saves money or it makes some money, or make things a little more efficient or faster. Now, I want to point out the uncomfortable truths here. Timelines may vary widely. So when you start applying for a job in month 4, you're probably not going to hear anything for the first few weeks, couple of weeks. It could take, on average, 3 to 6 months before you start seeing any type of tractions. Most people probably won't even apply to you. Or even if they do, there's other candidates as well, so you might not make it out of it. This is why it's important that from month 4, as soon as you start doing real projects, you start applying for jobs, because you're not feeling it yet, because you're still learning. And by time you start getting a little more confident because you have projects under your belt, this is around a 3 to 6 month mark, right? That's when typically you might start seeing results back, right? But the thing is, it's not always guaranteed. Depends on the climate, depends on a lot of things, right? So the main thing is, you have to start. That's the most important part. You can't get any response back if you don't do anything, right? The other thing as well is that competence creates passion. Once you start doing your real projects and you see, okay, you solved one, you solve another one, you start getting passionate about it because you start seeing results, right? And at the beginning, though, at the same time, progress may seem invisible if you don't get any feedback from the actual companies itself. And that's because, unlike when you're doing like a traditional job or anything else, when you do something is deterministic. You do something, you get a reward, or you get some type of feedback. In this, you have to build for a while. It's like going to the gym. You could build for a while, and after a certain amount of time, that's when you start getting feedback from it, right? So consistency is the actual hard part of that, right? But when it starts happening, it seems like it's an avalanche, because you've been building up all this time that it all of a sudden it all starts coming. It seems like out of nowhere, but you actually been building towards this, right? And to stay consistent, you want to create urgency early, right? A lot of times, if you don't feel that there's a deadline, that you're like, okay, well, I was supposed to go and reach out to certain companies this morning. I'm not going to do that because I don't feel like it. It doesn't feel like anything because you didn't see any visible progress in the first place. So it feels like it's not going to hurt, right? But it adds up. So creating urgency that under no circumstances you must miss, you have to hit these deadlines, that at the end of the day, they'll add up. And then you start seeing results after a certain amount of time has passed. Here's your action plan. Think of this as your checklist. Start tonight. No excuses. Just get in, start anything. Just build something at all this week. It doesn't matter how big or how small it is right now. The thing is, the hardest stuff is to get the ball rolling, right? Then month 1, do the foundations, right? That is learn Python, learn NumPy for the numerical calculation stuff, learn Pandas so you can deal with Excel sheets and data, and then also learn Matplotlib or Seaborn so you can actually visualize that, right? And then month 2, that is when you start using classic ML, like with scikit-learn, which is in Python, and that you learn the classic algorithms and basically how machine learning works in general without having such a deep neural network. And you'll learn how to actually do tests, how to actually train it, how to actually use it in inference, and the classic algorithms and classic things that still work today, like K-clustering or like linear regression, things like that. And then month 3, in this checklist, what you're going to be doing here, that's where you start learning more modern AI. That's like where you start learning PyTorch and all the things and dealing with big data and models that work today. And then month 4, you're going to take all that you've done from these 3 months, stop doing tutorials, and start applying it to real world projects where the data is not clean. It's in a domain that you understand, so you know what the outputs are supposed to look like, what success is supposed to look like. And you actually have a real portfolio that when you start also applying for real jobs during this month 4, this is apply for jobs as well, right? You actually have real projects to show them. And again, when you first start off here, it's going to feel overwhelming, right? But confidence comes from competence. By doing real projects, and the more you keep doing these, you're going to become more competent, and you're going to become confident as well. These days, AI engineering is mandatory. AI is everywhere. It's not whether it's going to come, it's already here. So you want to get in front of that. If you're not riding the waves, you're going to be under it. So you want to learn how to actually adapt that and how to build systems that actually create value. That's actually how you're going to stand out from all your competitors. Reinvention is normal. So what I mean by that is when I started off in like 3D, and then I started doing coding and webbing and web development and things like that. And now I'm doing AI, because you have to go with the trends of how the market is right now, right? So you're going to reinvent yourself a lot of times, and it's going to feel normal that at the beginning you feel like you don't know anything, right? And the other thing, start small. Doing small scripts and tools and code, they compound, because complication is just compounded simplicity. You do a lot of small, simple things, and once you start learning more and more, you chain them together, and you get much more complicated systems, and that's how you start dealing with more modern AI models and become a much more prominent AI engineer. So mainly focus on finishing an actual project at the end. That's going to be dabbling into just going in and doing random tutorials that by itself is just scattered. It doesn't actually solve a real problem. Whereas if you focus, having one focused project that actually solves a problem could be a career alone just by doing that. And that will beat out knowing 100 different little things that don't actually do anything at the end. And basically, what the biggest advice I would say is start today and procrastinate later.